In this video, we are going to learn how to identify the domain and range of a function from its graph. Now, this is important because the domain and range of a function help us understand what a function can do. Basically, the domain and range tell us what x values are allowed and what y values we can get. Let's start by clarifying the basics here. The domain, all possible x values, or inputs of a function. And the range, all possible y values, or outputs of a function. Now with function notation, the y values are also referred to as f of x. And it doesn't have to be f, it could be g or really any other letter. That's just the name of the function. This does not mean f times x, it's the name of the function and the input. So f of x and y really mean the same thing. So here are the steps for finding the domain from a graph. We look left to right across the x-axis, identify where the graph starts and ends horizontally, consider any gaps or breaks in the graph, and look to see if the graph continues beyond the graph paper to the left and right, or if it stops. All right, so here we go. Let's find the domain of this function called h. So we're going to look at we're working with the domain. So we're looking at the x-axis and working left to right. We notice that this function, well, it's these points here. So we have x values of -7, -5, -2, 0, and 5. So those are the values in the domain of this function called h. Here we have a function called f that's continuous from an x value of -6 over to an x value of +6. So notice going left to right along the x-axis, this function has x values all the way from -6 to +6, including -6 and +6 at its endpoints. Notice these points are filled in. Sometimes they're open, which means that those are the endpoints, but are not part of the function, or not part of the domain in this case. All right, so we want a way to describe all the x values between -6 and +6, including those endpoints. Well, we can say that -6 is less than or equal to x, which is less than or equal to 6. So in other words, x is in between -6 and +6. Notice we put equal bars underneath the inequality sign. That indicates that the endpoints are part of the domain. Here, this function continues forever to the right, but has an endpoint on the left. So looking at the x values along the x-axis here, we see that this function uses all the x's that are greater than -4, but not including -4. So we could say the domain is x is greater than -4. Now to find the range, we are going to look bottom to top along the y-axis. We'll identify where the graph starts and ends vertically. And we're going to consider any gaps or breaks in the graph. And look to see if the graph continues above or below the graph paper, or if it stops. All right, we're working with the range here, so we're switching gears, and now we're looking at the y's. What are the possible outputs for this function? So those are the y values. So we're going to look at the y values of these points. All right, so working bottom to top, this point here is a y value of -3. Point here is a y value of -2. And continuing up, our next point has a y value of 2. And continuing up, both of these points have a y value of 4. We'll just put it once. So the range of this function called h are the y values -3, -2, +2, and 4. Here we have another zigzagging function, and we are focused on the y values. Well, the lowest y value is -7, and moving up the y-axis, this function has y values all the way up to 4. Notice that we don't stop at 2 because the function goes above y equals 2, and it goes all the way up to y equals 4. So the range are all the y values in between -7 and +4. So we could say -7 is less than or equal to y, which is less than or equal to 4. In other words, y is in between -7 and 4, including the endpoints, because the endpoints are filled in. Now we're looking for the range of this function that stops or has an endpoint on the right, but continues forever to the left. So let's think about the y values of this function here. The y values of these points that are on this array, I guess you'd call it, go from -5 all the way up to infinity. So if we continued along this line forever, it would keep going up and up and up and up and up. So we can say that the range is y is greater than or equal to, well, the lowest y is -5. So y is greater than or equal to -5. Right, for this function, let's find both the domain and the range. This function is called the g function. For the domain, we're going to look along the x-axis to see what the x values are that this graph uses. Well, this graph uses all the x values from -5 all the way to +4. So we can say -5 is less than or equal to x, which is less than or equal to 4. In other words, x is in between -5 and +4, including the endpoints. Now for the range, we're going to look at the y values that this graph uses. The lowest y value is -4, and it uses all these y values all the way up to +9. There's the highest point right there. So we could say that the range of g are the y values between -4 and +9. I hope these examples have been helpful. This is Mr. Ela, signing off.